Hello everyone. Okay, let us start our discussion. In the first part, we did the first 25 questions of this past papers. Now let us continue from the 26th question. This question is based on balancing of equation. We have done a lot of questions on balancing, so it can be done. If you want to balance it, it will be how you have to put a 3 here and a 4 here and here are 5. Oxygen can be balanced at the last. So he's asking you what will be the total coefficients of the product. So what you want to add them. So the answer should be B 7. The relative molecular mass of a compound is 60. Which formulas are possible for this compound? So we have the molecular mass which is 60. We want to check which of these will be 60. If you add the masses of these, this will be 60, this will be 60, this will be close to 60, but it's not 60. How you can do it? You can just use the product table for the masses, like it is what 12 plus 3 plus 12 plus 2 plus 12 plus 2 plus 16 plus 1 based on the elements atoms. You can get it. It should be equal to 60. This is 60, this is 60. So our answer is what? Our answer is 2 and 3. Which sample has the least number of atoms? We want to see which one has the least number of atoms here. If you look at 1 mole of H2SO4, in 1 molecule of H2SO4 it will be how much? 5 plus 4 plus 1 3, 3 plus 4 7, 7 atoms. So in 1 mole you will times it with Avogadro's number. Here it is 1 mole again, but how many atoms are there in 1 molecule? 3 plus 1 4, 5 6 7 8. So it here in 1 molecule it is 8. For 1 mole you times it with Avogadro's number. Here it is 2 moles. So 2 plus 2 4. So 4 into 2 into Avogadro's number. Why 2? Because here it is 2 moles. 1 mole contain Avogadro's number, so 2 will contain double of Avogadro's number. Same is the case here. Again it is 4. So 4 into 2 into Avogadro's number, right? So the correct answer should be 28A. Why? Because it will have the least number of atoms. Avogadro's constant has the same value as the number of, which one should be correct in this? It is again Avogadro's constant. The answer is A. How? Because molecules in 1 mole of sodium iodine. We have 1 mole of sodium iodine. How many molecules will be there? Avogadro's number. 1 mole of chlorine gas, it is Cl2, so it cannot be, it will be double. 1 mole of solid potassium bromide, it is based on 2 elements, so it will be double. Ions, potassium will be K plus, Br will be minus, so it will be double. Protons in 1 mole of helium gas, it's only number of protons in helium gas, it's also not correct. So the correct answer is A part. Okay, this question it's part of here, but it's from chapter 9, so we will skip it. We will see it when we will do chapter 9. Which contains the same number of ions as the Avogadro's constant. Now we want to get like in which of these will have the same number of ions as the Avogadro's constant. If you look here, this is 0.5 mole of NaCl. NaCl will be what? Na positive, Cl negative. So half Na and half Cl collectively will be how much? 1 Avogadro's. So this is correct. But if you look here, it is Mg 2 plus and Cl negative. But what is it? 2 Cl negatives. So 2 Cl negatives. So it will be like how much? 1.5 into Avogadro's number. So it is not correct. Here again 3 is there. So 3 will you times with Avogadro's number. It is not still equal to Avogadro's. So the correct answer is A here. Okay, even if you select the fourth one, it is Mg 2 plus and O negative. But if you see, it will be what? It will be double of Avogadro's number. Why? Because it is 1 mole here. It is 1 mole. Here it is 0.5 mole. So half of Na and half of Cl, it will be how much? Equal to Avogadro's constant. So correct answer is A. Again, we want to balance. Lot of questions are there for balancing also. So if you will balance it, here it should be 2. Here it is 3. Okay. Here again 2 and here again 2. So when the equation is balanced using the smallest possible whole numbers, what is the coefficient of O2? So what do we get here? O2 has the coefficient of 3. Okay, this is equation balancing, so we can do it rather quickly. Moving forward, what we have next? The equation of a reaction occurring in a synthesis of methanol. Okay, the equation is given to us. What is the maximum amount of methanol that can be formed from 2 moles of carbon dioxide and 3 moles of hydrogen? Okay, we are given the quantities, we are given the equation. So if you see here, we have 2 moles of carbon dioxide and we have 3 moles of hydrogen. So directly moles are given, and we want to see the product. When the quantities of reactant is given and you want to see the product, you first need to find what? You want to find the limiting reagent. Here you see the ratio is what? The ratio is 1:3. Like 1 mole of CO2 reacts with 3 moles of hydrogen. You have how much? You have 2 moles. So 2 mole will react with how much? X. This is simple. X will be what? 6 moles. You need 6 moles, but you have how much? You have 3 moles. So which one is your limiting reagent? Hydrogen is your limiting reagent. It will control the product. Now 3 is giving you 1 mole. 3 moles is giving you 1 mole. You also have 3 moles in your stock. So answer is what? Answer will be 1 mole. How much product you will get? 1 mole of the product. Which solution contains 0.1 mole of sodium hydroxide? You want to check which of these values will contain 0.1 mole of sodium hydroxide. It's a concentration part, so you know the concentration formula is C is equals to N over V, and N is what? C into V. Okay, it's all as centimeter cube. It is better to convert it into decimeter cube, because here it is decimeter cube, so it is better to convert it. Just check, times them, both of them, all the time. The one which will give you 0.1 as your answer will be correct, but make sure, because this is centimeter cube, so you divide it. Like the correct answer for this is 34 is C. So you will, when you want to do it, it will be how much? 1, the concentration into 100 divided by 1000. So the answer is what? 0.1 mole. A cylinder of gas is at pressure 40 kPa. The volume and temperature are both doubled. So what is the pressure of the gas after these changes? See, this question is very much popular. You want to find the volume, right? No, you want to find the pressure. So here you have the pressure here. Pressure will be nRT over V. Okay, and after solving it, you are getting an answer of 40 kPa. So the pressure value is nRT over V is equals to 40 kPa. Now you double the temperature and volume. You double it. So it cancels, both cancels with each other. So there will be no impact. So still, if by doubling it, still you will get what? Same pressure, 40 kPa. Which of the following quantities have unit? Molar mass as a unit, and the unit of molar mass is gram per mole. Gram per mole. The empirical formula for compound is C2H4O. Which molecular formulas are possible for this compound? You are given an empirical formula and you want to pick, like, guess which can be like the molecular formula for this. Let us check. It is like, if you check one, C2H4, if you write it collectively, C2H4O2, like this is the molecular formula. If you derive the empirical formula, it will be what? CH2O. So it is not matching, so this A is not correct. If you look at B, 1 2 3 4 carbons, 3 plus 2 5 plus 2 7 plus 8 8 hydrogens, and 2 oxygens are there, right? How many oxygens are there? 2. Now what is common here? 2 is common, so if you derive the empirical formula, it will be C2H4O. Similarly, do the same thing, you will again get C2H4O. So what is the correct answer for 37? C is the correct answer. Calcium carbonate decomposes on heating. We are given a question, a very good question this is. Where it is? Yes. We have this equation. He says that when 50 gram of calcium carbonate are decomposed, 7 gram of calcium oxide are formed. What is the percentage yield of calcium oxide? You want to find the percentage yield. Percentage yield is what? Experimental over theoretical yield times 100%. This value which is given to you is basically your experimental yield. He said that when he decomposed 50 gram, he got 7 gram. So we want to find the percentage yield. For that, first we want to calculate what? Theoretical yield. We need the equation. We have here the equation. It is showing us that 1 mole will give you how much? 1 mole of the product. And you have how much? 50 grams. So it's better you convert 50 grams to moles first. When you will convert it, you divide it with molar mass of calcium carbonate, which is like 40 plus 12 plus 3 into 16, it's 100. So you will have how much? 0.5 mole. You have 0.5 moles. So if 1 mole is giving you 1 mole, the ratio is 1:1, so 0.5 should give you how much? 0.5 mole. You should get 0.5, but you are getting how much only? This much, 7 gram, which you convert into moles to check the yield. It is like 7 over 40 plus 16, it's around 0.125. 0.125. So when you do it, when you will solve it, how will you get the answer? Experimental yield, which is 0.125, divided by theoretical yield, which is 0.5, times what? 100%. When you do it, 0.125 divided by 0.5 times 100%, the answer is 25%. This is the correct answer for this. Okay, little bit trickier question. You have grams, you convert it into moles first, you got the yield, theoretical yield, and then you find the experimental yield. Again, we have equation balancing question. I think we can do this. It is not that much hard. The correct answer for this question is D. Okay, what is the total of all the coefficients? You want to add the coefficients in this case to get the correct answer. It will be like 2Na, 2H2O. Again, you need the 2 here, and when you will solve it, you see 2 plus 2 plus 2, 6. 6 plus 1 is 7. What is the total number of ions present in the formula Al2SO4 3? You want to find the number of ions. You see, this is a metal and this is a polyatomic ion. See, if you go reverse, what is the charge valency of aluminium? It is Al 3 plus, and sulfate ion is what? SO4 2 negative. If you even forgot, you can check it from here, like this is 2. Now when you write the formula, it goes here, it goes here. So it is 3, it is 2. Total how many ions are there? 5. So 5 ions are present in this formula. A 4 gram sample of sodium hydroxide is dissolved in water and made up 500 centimeter cube of aqueous solution. What is the concentration of the resulting solution? You want to find what? We want to find concentration, and all the units are decimeter cube. Here if you look at the units, mole per decimeter, mole per decimeter. So what we have to do first, we have to check the units, because we know that when we are working on concentration, concentration is C. Like when we want to have the concentration, the formula is C is equals to N over V. N is the number of moles and V should be in decimeter cube. So we have here, it is 4 gram. So first we do what? We convert it into moles. So we have it is 4 over 40. This will be the moles. Divided by what? This is 500 volume divided by 1000 to convert it into decimeter cube. And what should be the answer we will get here? It will be 0.2. So the answer is B for this. Methane burns in oxygen gas to form carbon dioxide and water. Keep this thing in mind. Anything in combustion reaction, if it is complete combustion reaction, it's always done in the presence of oxygen and you get carbon dioxide and water. If it's incomplete combustion, we get carbon monoxide when the oxygen supply is limited. So we have CH4 plus O2 it will give us what? CO2 plus H2. This is the equation we will get. If you balance it, you have a 2 here and you have a 2 here. Now it is saying how many moles of carbon dioxide will be formed from 8 grams of methane. 8 grams, so convert it into moles, because the equation shows you the relationship in moles. So if you have in grams, first convert it into moles. So how many we have here? 8 grams. So we do 8 over 16, which is like 0.5, because 16 is the molar mass. So 1 mole is giving you how much carbon dioxide is there? How many moles of carbon dioxide you want to find? So 1 mole is giving you 1 mole. So 0.5 will give you how much? 0.5, because the relationship is 1 mole is giving you 1 mole. So 0.5 will give you 0.5. So the answer is B. You want to find the empirical formula in the compound which has 50% by mass of X and 50% by mass of Y. We don't know the names, but we know their masses. So when we know the masses, it's completely fine. We say it X, we say it is Y. It is 50. So 50 divided by the mass, which is 20. It is also 50 divided by the mass, which is 25. So what do we have here? It will be like 2.5, and here it will be like 2. To make it a whole number, we times both of them with a common number 2. So it becomes what? X5 Y4. D is your correct answer. Okay, assuming complete reaction, what volume of this moles per decimeter cube potassium hydroxide solution is required to neutralize aqueous sulfuric acid? Again, you see it's neutralization, it's titration, acid base. So it's better to have the equation, because it's only the equation that can tell us that what is the mole ratio. So what is potassium hydroxide? It is KOH. It's a very famous base. H2SO4. It's an acid base reaction. You will always get salt and water. So this is the metal part. This is the sulfate ion. You know that the K is +1 and SO4 charge is 2 negative. You should memorize it. This will go here. It will come here. So the formula of the salt you will get is K2SO4, and with it you will get also water. Acid base, salt and water. If you balance it, you will have here 2 KOH and here you have a 2. Okay, now you see here you want to find the volume of this base. We are interested in volume of this base, but what we are given only the concentration, which is 0.2 mole per decimeter cube. We are only given this concentration. Okay, we have not got the number of moles, we don't know, so volume we cannot calculate. But look at the other side, we have both things. We have the volume also, which is 25 centimeter cube, or 0. We divided by 1000, so it will become decimeter cube. And we also have the concentration, which is C, 0.2. From here, what we can get, we can calculate the number of moles, right? So when we do it, we can do it like C is equals to N over V. So N is what? C into V, right? We will have C into V. So when you solve this, it will be what? 0.2 into 25 over 1000. We get around 0.005 mole. So these are the moles of acid. Now if you look at the equation says that for 1 mole of acid you need 2 moles of the base. For 1 mole of acid you need 2 moles. If this is the number of moles, for the base you need to times it by 2. Why does 2 come? Because according to the equation, for 1 mole we need how much? 2 moles. So if we have 0.005, we have to times it by 2. We get how much? 0.01. Now we have what? We have the concentration, we have the number of moles. We divide them same like using this formula. We get our volume. Volume is in centimeter cube. So when you get the answer, times it by 1000. So what will be the answer of this one? The answer of this one is 50. Your answer should be C. Consider the following reaction. Nitrogen plus hydrogen is giving you NH3. The mole ratio is what? 1:3. Okay. It is gases, so volume is also acceptable. He says that you have 25 decimeter cube of nitrogen. This one we have 25, and this much we have 60. Now we want to see how much product we can get. So the mole ratio is what? Mole ratio says 1:3. Like for 1 decimeter of gas, you need 3 decimeter cube of hydrogen. But you have how much? You have 25. For 25, how much you need? X. So the value of X is how much? 75 decimeter cube. You need 75 decimeter cube. But you have how much? Here you can see you have how much? 60 decimeter cube. It means you have short. When you have short, it means this is your limiting reagent. So who will control the product? This one will control the product, right? So we have 3:2. Why? 3 is giving you how much? 2. But you have how much? 60. So 60 will give you how much? X. Okay, so the value of X will be how much? 2 60s are 120. 120 over 3, 40. So our answer is what? 40. Okay, limiting reactant is very important here. The temperature and Kelvin of 1 decimeter cube of an ideal gas is doubled and pressure is tripled. So what is the final volume? Again, this is a gas one. PV equals to nRT. Volume will be what? nRT over P. Okay, now what we have done, this is equal to 1. Okay, volume is 1 decimeter cube. We did what? We doubled the ideal gas doubled, temperature is doubled, sorry, I forgot here. Temperature is doubled and the pressure is tripled. So it is like what? The factor of 2/3. So the change in what? 2/3 is the change. Okay. On complete combustion, a sample of hydrocarbon compound produces 1.5 moles of carbon dioxide and 2 moles of water. So we have a hydrocarbon. We don't know which hydrocarbon. Let's say CH. Any of the 4 can be it. It is combusted. So we have O2, and where we have what? 1.5 moles of CO2, and we have 2 moles of H2O. We wrote the combustion equation. Now we want to see which one is the correct one, because we are told here that we have 1.5 mole of CO2 and 2 moles of H2O. So we have to figure it out which will give us the correct answer. If you try C2H2, it cannot be correct, right? So which of them will give you the correct answer? If you have here C3H8, okay, C3H8, and here you have half, it will give you the correct answer. If you can, you can do it with the help of balancing. You have to balance it. Which one of you will give the correct answer? This one will give you the correct answer. 48. Question number 48. When excess barium chloride were added to a sample of this particular big compound to determine the amount in moles of sulfate present, this much of barium sulfate was obtained. How many moles of sulfate ions and iron ions are present in the sample of this? For solving this question, first you need is a balanced chemical equation between barium chloride and FeNH4 twice, SO4 twice. So what is the equation? We have BaCl2 plus FeNH4 twice, SO4 twice. It will give us what? It is a replacement reaction. This Ba will combine with SO4. You will get what? You will get BaSO4. Okay, and what next you will get? This chlorine will replace here, and you will get FeNH4, okay, twice, Cl2 twice. When you want to balance the equation, you should put a 2 here, and you must put a 2 here. So the equation is balanced. Why do we need this equation? We need this equation to get the mole ratio. We need the mole ratio. Here if you see, okay, we have this value is given for BaSO4. It means this much of moles of BaSO4 we have. In the relation you see, if this is 1, this is 2. Like if we have 1 mole of this, we are getting 2 moles of this. So it means we have 1:2. If we have 5.02 into 10 raised to power minus 3 moles of BaSO4, so how much we will have for this? We will have also half, like it is 1:2. If we say this is x, so this should be x over 2. So when we divide, when you will solve this, like 5.02 into 10 raised to power minus 3 divided by 2, you will get around 2.51 into 10 raised to power minus 3 moles. It means you have this much moles of this. Now if you look at the formula, if you look at it, we'll clean it so that you can clearly see the formula. If you leave the mole ratio of which ones you want to go for, sulfate ions and iron ions. If it is iron is 1, SO4 is double. Okay, it is like double, and you have only 2.5 into 10 raised to power minus 3 moles. So if this answer you select is A. Why? Because if you have iron this much, it is the sulfate ions are double. We don't have this much of quantity because the total amount is this. We don't have this much, and if we choose this one, like which is same, then this is 4 times, but it's not correct. We have here 2 times, double. So correct answer for this is what? A. A is the correct answer for this. What volume of 0.5 moles per decimeter cube of sulfuric acid solution is required to react completely with 10 gram of calcium carbonate according to the equation below? We are given an equation. Okay, we have given the volume of sulfuric acid, which is, sorry, not the volume, we have asked the volume, and the concentration is given, which is how much? 0.5 mole per decimeter cube. The concentration is given, we want to find the volume. So you know by now that the formula is what? C equals to N over V. So by any means we have to find the number of moles here. But we are given what? We are told that it's 10 gram of calcium carbonate. It's grams, better to convert it into moles. So it is what? 10 over 100. It will be 0.1. Now look at the relation. If 1 mole is reacting with 1 mole, because the mole ratio is what? 1:1. So if you have 0.1 mole of this, how much acid you need also? 0.1 mole. So 0.1 will be 0.1 mole. So what will be the number of moles of the acid? It will be 0.1. Now you have the concentration, you have the number of moles. So how can you find the volume? Volume is N over C. Okay, when we do this, what answer we get here? We get here 200 centimeter cube. Just when you get your answer, times it by 1000 to convert it into centimeter cube. Which expression gives the amount in moles of a substance if the mass is given in grams? If the mass is given in grams, we use the formula what? Given mass over molar mass. Given mass over molar mass. What is the total number of atoms in 0.2 moles of propanol? So we need to find the total number of atoms. In one molecule, how many are there? 3 plus 1, 4, 5, 6, 7, 8, 9, 10. In one molecule, 10 atoms are there. So in 1 mole, how many molecules are there? Avogadro's number. We times it by 10. Why? We get the value of 1 mole. But we need for 0.2 moles, so we times it by 0.2. So what's the answer we get here? We get here, for this is 51, we get C. This is a Equine equation balancing, mistyping here, it is C3H4. Okay, we want to balance it. When you will balance it, it should be 4O2. Then we have how much CO2 here? 3 CO2 and 2 H2. But he has asked us the coefficient of O2. The coefficient of O2 is 4, so the correct answer is C, 4. Ethyne reacts with oxygen according to the equation below. What volume of oxygen reacts with 0.4 decimeter cube of C2H2? Okay, equation is given. What we have here, the relation is what? 2:5. Because here we have 2, here we have 5. It's 2:5. 5. So what volume of oxygen reacts with 0.4 decimeter cube? So here it is 0.4. We want to find it. We do an x. So we cross multiply. 2x is 5 into 0.4. So the x will be what? This one divided by 2. So what should be the answer here? The answer is 1. Ethyne reacts with oxygen according to the equation below. What volume of oxygen reacts? Is the same question, I think. Yes, 54. See, repeat question. What is the coefficient of H plus? Again, it is redox titration. We will do it later in the electrochemistry chapter. How many hydrogen atoms are in 1 mole of ethanol? So in 1 mole of ethanol we want to do. I think this is a repeat question also. Like in one molecule we have 6 hydrogens. So in 1 mole how many molecules are there? Avogadro's number times by 6. So we get our answer. Okay, I think the correct one is B, the correct answer. What is the coefficient of H2SO4 when the following equation is balanced? Again, it's a balancing equation. We can try. Here we have a 4. Okay, here 3, and I think it's balanced. So the coefficient of H2SO4 is 4. So the sixth answer is 4. Airbags in car inflate when sodium azide decomposes to form this equation. Calculate the amount in moles of nitrogen gas produced by the decomposition of 2.52 moles of NaNO3. Equation is given, very simple one, 2:2. We want to see the moles of nitrogen gas. Okay, so it's not 2:2, it's 2:3, because it's just one reactant, so no need for limiting reactant. 2 is giving you 3. So 2.52 will give you how much? We put an x here. We do the cross multiplication. 2x is 3 into 2.52, and the x value will be how much? It will be 3.78. Okay, what volume in centimeter cube of this much concentration of acid is required to neutralize? We have a base, we have BaOH twice. So first, it's a titration question. It's better to write an equation. We have HCl plus BaOH twice. It will give us what? BaCl2 plus H2O. You know how to write the formula. Ba is 2 plus chlorine is 1 negative, so surely it will be BaCl2. Okay, now from here what we can do, same repeat again, the same pattern of titration. We have the volume, we have the concentration. So from here we can use the concentration formula and we can find the number of moles, C into V. Now if you'll see, this equation should be balanced, so we have to put a 2 here and we have to put a 2 here. So the ratio is 1:2. So whatever moles we get here of this base, for acid we times it by 2, because the concept ratio is 2:1. So by this you will get the moles of this acid, right? And we have the number of moles. Again we use the concentration formula, C is equals to N over V, and we get the answer, and this answer is supposed to be C. I did this one little quickly because we have done that before also in many questions. So you should also do some calculations. Okay, that sums up our paper 1 questions. In the next video we will talk about paper 2 questions. You people try to solve all the questions, so more practice, it will be good for you. Thank you so much. See you next time.